What we're going to do today is take a look at some word problems, and starting off easy, what strategies can you use to solve word problems? Well, step one is you have to read them carefully. Step two is try to understand what you're reading and maybe make a picture or a diagram or a chart. Something to help you see what's involved in the problem, and then write an equation, solve the equation, and then see if what you get as an answer makes sense in the problem. So this is what we're going to do. Starting off easy here, this is the length of a rectangle is 6 more than twice the width. So how would we possibly set that up? Well, since they're mentioning a rectangle, I suggest you draw a rectangle. Now, it doesn't have to be proportional or anything. It's just a diagram to put some information into. Now, the length of the rectangle is 6 more than twice the width. So what is it we know, in a sense, nothing about? Well, we don't know anything about the width. So our width we're going to call W. Now we start looking at the length. What is the length? Well, we see it's twice the width, and that would be 2W, and then 6 more. So based on the information we have, we've made a diagram and we've put this information in. Now, we don't have an equation here, but if they were to say this is a certain amount, we could make an equation. But if we were going to figure area, that would be one thing. Or if we were going to figure perimeter, and we'd have to handle the information differently. So for area, it would be W, which is width, times the length. That would be taking this information using an area formula. Or if we wanted to find perimeter, now our lengths are this. And then our widths are this. So the part we're lacking is what is the area. If we had a number here, we'd have an equation. And for perimeter, if we had a number here, we'd have an equation. But in this particular lesson, we're just trying to give you some background, word problems in algebra, and then converting them into algebraic expressions and later equations. All right, in this next one, what we're going to feature is we're selling rose bushes that cost this, and small magnolia bushes that cost this. And at a particular nursery, that day they sold 31 plants altogether. They want you to write an expression for the revenue that these plants would give. So this is where we're going to look at this part carefully. How many plants altogether? Well, again, I suggest you make a little box. And this box is going to be the total number of plants that you sold, which was 31. Now, what I'd like to do, without knowing, I want to divide this 31 into two parts, such that one part would be the roses that we sold, and the other part would be the magnolias. And it's nice on this kind of wintry day thinking about nice plants and flowers and things. But getting back, we have here our 31. How do we divide 31 into two parts? Or in fact, any number into two parts? Well, I'm going to just draw a line. And I'm going to say, let part of this be x, an unknown amount. What would the other part be? Well, it would be the total 31 minus the x. So this is sort of a general way to divide anything, a total of something, into two parts. This is going to work for anything. So part of it is x, and then if we take this x away from the 31, that's the other part. So how do we go to set it up? Well, let's say the roses, which cost $15.45, times x, that would be the revenue generated from the number of plants. In this case, we're defining these as the roses that we sold, plus, for the other amount, it would be $7.45 times the other part of the 31, which is 31 minus x. So this expression is an expression for the total revenue for this number of plants we're selling for the roses. This number of plants, the other part of our 31, that were the magnolias, and that would represent our total revenue from the sale of these plants. Again, this is not an equation. We're just thinking of setting it up into a word problem. All right, this is another type of problem, and we actually are getting now into an equation where it says Stella is 3 times as old as her sister Terry. In 4 years, Stella will be twice as old as Terry. What are their ages now? Now, the first time I read this, I had to read it again. But then I started to think, well, what do I know? What can I put here? And I can start off by defining some of what we know from our word problem. What is Terry's age? We don't know that. So I'm going to call Terry's age T. Now, we know Stella's age is 3 times Terry's age. So that's 3T. So we didn't know Terry's age, but we know Stella's age is 3 times her age. So that's sort of what we know. Now what they're saying, Stella's age, 3T, in 4 years. So if this is Stella's current age, in 4 years, that would be the sum of Stella's age in 4 years. Her current age, 4 years more, they're saying will be twice what Terry's age will be in 4 years. Now, Terry's age is T right now, but in 4 years, this is what it will be. So, once again, we didn't know what Terry's age was, but we knew that Stella's age is 3 times that. And then in 4 years, Stella's age will be twice Terry's age in 4 years. We had to put that in parentheses. So that's our equation. And working with word problems, it just doesn't happen, but it's through a process, thinking, analyzing, and now that we have an equation, and this makes sense to what we have here, we now solve the equation. So we got to get rid of parentheses. 3t plus 4 equals 2t plus 8. We're going to subtract 2t from both sides. This leaves us with a t. We're going to subtract 4 from both sides. That leaves us with a 4. So now that we know what Terry's age was back when it started, it was 4 years, what will Stella's age be? Well, Stella's age will be 3 times t, 3 times t, 12. And if you put that into this equation, the t as 4, it checks out. So what are their ages now? That is currently, not in 4 years, but now. Terry's age is 4, Stella's age is 12. Here's another very typical kind of problem that you might run into. It says Andy has some $10 and $20 bills in a shoebox under his bed. Doesn't believe in banks. He has a total of 42 bills that are worth $600. So the 10s and 20s, if you add them all up, it's $600. But they're wondering, how many $20 bills does he have of those 42? So again, you'd have to read it a number of times to kind of get the sense of what are they asking. And then you would, I think, move to an idea of, here's your shoebox. And in this shoebox, there are 42 bills. Now, we know there's 42 bills, but we don't know how many 20s and we don't know how many 10s. So what technique did we mention earlier on this video to think of how do we divide that into 2 parts? And we said we put a line. Part of this will be x, and then the other part would be 42 minus x. And now we've divided this 42 into 2 parts. And one part of that will be our $20 bills, and the other part will be our $10 bills. And do we know which one it is? Well, not yet. But as soon as we say this, that what's a $10 bill worth? Well, a $10 bill is worth $10. And we're going to say, let those be the x. Now you could have switched it around. In fact, you know what I'm going to do is I will switch it around. Because they're asking us how many $20 bills. So I'm going to let the $20 bills be the x. And you could put that over here like $20, and this will be the 10. So this will be this one, 1042 minus x plus, and our $20 bills are worth $20. And then our total is we have all of this together is worth 600. So again, this is a portion of the $42. This is the other portion. I mean the 42 bills, this is the other portion. And we're saying these have a value of $10 and these have a value of 20. And the total value, this would be in a sense the revenue, is equal to 600. So what do? Well, we're going to solve it. This is going to be 420 minus 10x, just distributing, and this will be plus 20x equals 600. We're going to subtract our x's here, and we get 420, 10x equals 600. I switched them around to have it look more typically like an equation. I'm now going to subtract 420 from both sides. And this gives me 10x equals 180. Now I divide both sides by 10, and this gives me x equals 18. And lo and behold, that is the answer. Now, had I done it the other way, I would have gotten the number of $10 bills. Then I would have had to subtract that from 42 to find the other. But since I set it up that x is my $20 bill number, it solves it. And you might say, well, how did it do that? Well, that's the marvel of algebra. Again, these fellas that developed this some years back, they saw this and realized that if you put, like letters that stand for something and manipulate those with the techniques we've had, you get a solution. So algebra is like a great help for arithmetic. Okay, another problem very similar to the one we just did was you had a school play in which you sell two types of tickets. Child's ticket is $3. And adult tickets are $7, and you sold a total of 114 tickets, bringing in $626. But you're wondering how many adult tickets were sold. Again, the word problem was more wordy. I kind of trimmed it down here. And you might say, isn't this just like the one we just did? And the answer is yes. So this will be your little sales box in which you had sold 114 tickets. Now we're going to say a part of those tickets were the children, and let's call that the C letter. We could use X or N or any number, but this is the children's tickets. And then the adult tickets are going to be the 114 minus the children's tickets. Now notice the other time since we're looking for adult tickets, we should have solved for A, but I'm going to just show you this other technique of solving for the other letter and then doing some subtraction. So how many adult tickets were sold? Well, what was the cost of the child's ticket? Well, $3, and we sold this many tickets. And what was the price of the adult tickets? Well, $7, and we sold this many. And our total revenue was $626. So again, this was the cost of the child's ticket, and the number of tickets was C for the child's tickets. We said this other part were the adult tickets, and they were $7 each. And this was the total revenue. So it's going to be 3C plus 7 times this, which is 798 minus 7C equals 626. And all we did is clear parenthesis, distribute. And now we're going to group our C's together, and we get a negative 4C. And I'm going to subtract this from both sides. Transpose is subtracted from this and get a negative 172. And now I'm going to divide by negative 4. And I get C equals 43. Now, if 43 were my children's tickets sold, remember our question is, what was the adult tickets sold? Well, I would have to subtract 43 from 114 and get 71. So the adult tickets were 71. Now, had I used this as A and this as 114 minus A and set it up that way, I would have ended up with adults, or the A, equaling 71. But you could do it either way. This involves doing some substitution once you find out the children's tickets. This was 43, and this one will be, in a sense, 71, and they add up to 114. Again, you'll get some like this as you work word problems. Okay, here's one with a little twist. Matt has 2 different stocks. One stock is worth $5 more than the other. So this will be one stock, X, and the one that's worth $5 more is X plus 5. He has 11 shares of the more valuable stock and 39 shares of the other. How much is the more valuable stock worth if his total assets in stock is $1,505? And again, you may have to read this more than once, but here's our 2 stocks, and here they're telling you that you have 11 shares of the more valuable stock, which is this one. And you have 39 shares of the other. And the total worth of it is so we're just going to solve it. Again, this is the more valuable stock, $5 more than the other. This is, you have 11 shares of that, 39 of the lesser, and it equals that. So 11x plus 55 equals 39x equals 1505. And you group these together. This will be 50x. Subtract 55 from both sides, 1450. Divide both sides by 50. X equals 29. So if the lesser stock is 29, what would be the cost of the more expensive stock? Well, $5 more for $34. And that's it. Again, this wasn't too difficult. We're going to keep working on some of these as we move along and see what we can do to help you master working with word problems.